This is 4.3 lesson on right triangle trigonometry. This next slide is a very important slide. It's the 6 trig functions. The ones on the left are more popular, used more often. They're what we call the big 3 for short. The way to remember it is using SOHCAHTOA is the way to remember it. Sine represents opposite over hypotenuse, so that's the SO. Cosine represents adjacent over hypotenuse in a right triangle, and remember we remember that is CA. Tangent is opposite over adjacent, which is TOA. Then you just find the other 3 by the inverses. And the way I remember the inverses is I do the sine, cosine, and tangent in that order. And then these are the opposite S and C. So it's cosecant, and then you just reciprocate that sine function. So now you have hypotenuse over opposite. The way I remember the secant, it's the opposite. So hypotenuse over adjacent, and then cotangent is a reciprocal of the tangent. So that's adjacent over opposite. Make sure you have those 6 trig functions in your notes. We're going to use them a lot in this section. Alright, here's a right triangle. The right triangle has 3 sides. You have to pay particular attention to identifying the 3 sides. Students make mistakes. They maybe say the wrong opposite or adjacent, and then when they go use the trig function, they get the answer wrong. So it's always a good idea to always draw the triangle out and label the 3 sides. The way that I remember the 3 sides is, here is my right angle, so the hypotenuse is always opposite the right angle, which is always the longest side in the triangle too. And then the next thing I remember is, here is my theta, the angle I'm working with. It is always opposite theta. And then the last one is either just remember, you don't remember where adjacent goes, and then you just, that's your last side. Or the way you remember it is, adjacent is found between theta and the right angle. So those are the 3 important sides in a right triangle that goes with the 6 trig functions. All right, here's our question that we're gonna say. We have this right triangle, and we're given two sides, side 3 and side 4. And we want to go out and find the value of these 6 trig functions with the angle theta. So what might we want to do first?
Start from side.
Start by sine? Does anyone disagree with that? Yes, Morgan. Find the hypotenuse first, because we have to use the hypotenuse in the trig functions. And we don't know the hypotenuse, so how do you find the hypotenuse? Pythagorean theorem, a squared plus b squared equals c squared. Great. So what is our c value?
5.
Well, it will be 5. It's a very popular right triangle. Not always will they be that nice. So we'll just let that be c squared. And then we substitute a and b in. And we solve for c. So we get 16 plus 9 equals c squared. 25 equals c squared. So then c equals plus or minus the square root of 25. So c equals 5. Why do I not want the negative in this triangle? It's a distance, doesn't exist. So now we can come over here and label side C, which is 5. Before I go out and identify the 6 trig functions, go ahead and physically write on the 3 sides. What do those 3 sides? Because you'll make less mistakes. So here is my side, or my angle theta, in the bottom corner. So let's talk about the 3 sides. Which one is the hypotenuse? The 5. We kind of already talked about that. So I just write hypotenuse for short there, height. Then where is my opposite? What distance is the opposite? 4. So opposite. And then what's my adjacent then? 3. Good. So then I tend to do in the specific order again, sine, cosine, and tangent first. And then I do the 3 inverses by just flip-flopping those, reciprocating them. So sine of theta equals cosine of theta equals tangent of theta equals. So the sine represents opposite over hypotenuse. So what are we going to put in there? 4 over 5. Cosine is adjacent over hypotenuse. 3 over 5. And then tangent, we remember it as by TOA, opposite over adjacent. Opposite is 4, adjacent is 3. Leave them as a mixed fraction, leave them as fractions. And then I want to find the inverses. So what's the first inverse?
5 over 4.
What's the function? What's the inverse of the sine function? Cosecant. So for short, we write it like that. What's the inverse of the cosine? Secant. So we write it for short. Looks like this. And then the inverse of the tangent? Cotangent. Now what do we do with those fractions on the left? Flip them. Reciprocate them. So that becomes 5/4, 5/3, 3/4. Remember this from geometry a little bit? Stop the recording there.